Pure substances and mixtures. Each of the substances that we use is made up of tiny particles. Matter present in our surroundings can be classified as pure substances and mixtures depending on their nature. What are pure substances? Materials made of particles of identical nature are called pure substances. Molecules of water, common salt, and gold have their own unique properties. In saline water, both particles with properties of salt and water are present. What are mixtures? The substances made of particles with different nature are called mixtures. That is, a mixture is a combination of two or more substances which are not chemically same and do not chemically react together. For example, look at the mixture of sand and sugar. A mixture has the same properties as that of its component elements and can be separated by physical means. In a mixture of sugar and sand, even if we increase the volume of sugar or sand, the mixture remains same. So it implies that in a mixture, the components can be present in any proportions. When we dissolve common salt in a glass of water, we will obtain salt solution. Similarly, put some mud in a glass containing water and stir it well. We will obtain a mixture with solid particles of mud dispersed in water. By carefully observing, you will find that in common salt solution, no salt particles settle down to the bottom of the glass. But the glass containing the muddy water, some solid particles settle down to the bottom of the glass. This explains that mixtures have different compositions. Accordingly, mixtures can be classified as homogeneous and heterogeneous. Many homogeneous mixtures are commonly referred as solutions. In heterogeneous suspension, the solute particles do not dissolve, but they are suspended throughout the solvent. Separation of mixture using separating funnel. The choice of the method of separation of components depends on the properties of the components of a mixture. Let us do an experiment to separate the mixture of oil and water using a separating funnel. Separating funnel is an apparatus used to separate immiscible liquids from their mixtures. To do this experiment, you require a separating funnel, stand with a clamp, filter funnel, beakers, and the mixture of oil and water. Take a filter funnel and place it on the clamp of a stand. Pour the mixture of oil and water into the separating funnel through the filter funnel. Oil and water will appear as separate layers. Remove the filter funnel from the separating funnel and close the separating funnel using a lid. Take the separating funnel from the stand. Invert the funnel and shake it gently. Slowly open the stopcock of the funnel to release the pressure inside the funnel. Place the separating funnel in the stand. Oil forms the top layer and water forms the bottom layer. Take a beaker and place it below the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully onto the beakers. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. The immiscible liquids separate out in layers depending on their densities. The denser liquid will fall to the bottom, forming the lower layer, and lighter liquid forms the top layer. We know water is denser than oil. We have seen how to separate the mixture of oil and water which are immiscible using a separating funnel. Simple distillation. Let us see another method of separating mixtures of acetone and water. For doing this experiment, we require stand with the clamp, a mixture of acetone and water, porcelain chips, heater, thermometer, flask, and ice cubes. Take a mixture of acetone and distilled water and pour it into a 250 ml RB flask. Clamp the RB flask to a stand and place it in a heater. Put some porcelain chips into the RB flask to avoid bumping while boiling. Connect a distilling head to the RB flask and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Then, connect a vacuum adapter to the water condenser and connect a 100 ml RB flask to the vacuum adapter. Take some ice cubes and place the RB flask in it. Connect a rubber tube between the tap and the inlet of the condenser to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heater to 56 degrees Celsius and allow the mixture to boil. At 56 degrees Celsius, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in the liquid form. Water is left behind in the distillation flask. Acetone boils at 56 degrees Celsius and water boils at 100 degrees Celsius. Simple distillation is used for the separation of a mixture containing miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Fractional distillation. We will study another method of separating components of a mixture. This method of separation is similar to distillation. fractional distillation is used for the separation of two or more miscible liquids of which the difference in boiling points is less than 25 degrees Celsius. Let us do an experiment to separate a mixture of methanol, ethanol and water. We require stand with clamp, a mixture, heater, porcelain chips, RB flasks, thermometer and ice cubes. Take a mixture of methanol, ethanol and water. Pour it into a 250 ml RB flask. Clamp the RB flask to a stand and place it in a heater. Take some porcelain chips using a spatula and put it into the RB flask to avoid bumping while boiling. Connect a distilling head to the fractionating column and connect a thermometer adapter to the distillation head. Insert a thermometer through the thermometer adapter. Then connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask to the vacuum adapter. Place the RB flask in the ice bath. Connect a rubber tube between the tab and the inlet of the condenser to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that the water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heater to 65 degrees Celsius and heat the mixture to boil. At 65 degrees Celsius, methanol vaporizes and the vapors first rise through the fractionating column and pass through the condenser. Condensation occurs and methanol is collected in the receiver flask in the liquid form. Remove the RB flask containing methanol and connect a new RB flask to the vacuum adapter. Again, set the temperature of the heater to 78 degrees Celsius and heat the contents of the RB flask. At 78 degrees Celsius, ethanol vaporizes and the vapors rise through the fractionating column and pass through the condenser and condensation takes place. Now, ethanol gets collected in the receiver flask in the liquid form, and water is left behind in the distillation flask. Here, the boiling point of ethanol is 78 degrees Celsius and that of methanol is 65 degrees Celsius, which has a difference in boiling point less than 25 degrees Celsius.